Okay, hello, my name is Bartosz Golaszewski. I'm based in France. I'm originally from Poland, and I have been working in the embedded Linux space for 16 years, actually, not 15. I maintain the GPIO subsystem in the Linux kernel and the new power sequencing subsystem, and also the counterpart in user space for the GPIO subsystem, which is libgpiod. I also contribute to many other open source projects, and I have a weird hobby of jumping out of perfectly good airplanes for fun. I'm here on behalf of Linaro. Check us out. We make we make Linux ARM run well on ARM. I'm personally in the Qualcomm landing team, and this has been what I've been doing professionally for the last couple of years. And today I'm gonna be talking about GPIO and sysfs and the sysfs class. So over the course of the last years, I've given several talks about libgpiod and about how I would prefer to remove the old legacy sysfs class from the kernel and why the character device is better. And I've been asked several times, why do you want to remove sysfs? Like, what's wrong? It's been around for so many years. It's useful. Why do you hate it? And the answer to this is I don't only hate sys class fs. There is a deeper problem to it. It is a bad interface, and it cannot really be improved now that it's been carved in stone for many years, but the problem is just much more complex. So GPIO lib, the kernel subsystem for GPIO, has been around for a very long time, and it has a problem with craft. It has accumulated a lot of unnecessary things. And I've talked about it in detail during my talk last year, or was it 2 years ago? I'm not sure. So what's the problem? GPIO lib has been around for 2 decades. That means that it has been created way before we even had a driver model in the kernel. And it has been modified and improved by many people, had several maintainers, and the main users for a long time for GPIO lib were ARM and MIPS in the dark times of board files. This is when the entire driver model, it wasn't even there, was very fragmented. The drivers would be implemented ad hoc under Arch in board files. This has caused a lot of things being implemented, just caused a lot of bad engineering, bad programming. And what we ended up with now is we have two interfaces in the kernel for using GPIOs. We have the modern one, which uses descriptors, opaque structures, which you get assigned in firmware, in DT or ACPI, and then relevant drivers can retrieve their GPIOs and use them, and a legacy number space based system where you basically have magic numbers and you request GPIO 42 for no reason. It has nothing to do with hardware offsets of controllers. So, yeah, as I said, many people have tried to improve it. We have made a lot of advancements recently. We now support, for instance, hot pluggable USB chips, which wasn't the case before. But still, we are stuck with these two interfaces. So why actually would I want to remove the global number space, the legacy interface from the kernel? So first of all, having two interfaces for doing the same thing is just bad programming. So that alone would lead to a lot of code unduplication. But also, the legacy interface is just bad. So first of all, magic numbers. It allows basically any driver to fetch any GPIO that it wants, even if nobody said that it's allowed to. There are many drivers still in the kernel which use a hard-coded base GPIO number because if you have several controllers and they come up at different times, the probe ordering can change, and then the numbers will not be the same. They will not be what you expect. So this is what led people to just hard code the base number in their GPIO drivers. And again, that's not unnecessary if you use a proper descriptor-based interface. And finally, since I do maintain that subsystem, I have a personal interest in reducing the maintainership burden. What's the way? First of all, in the kernel. In the kernel, we still have drivers that use the old interface. That is not a hard problem. Basically, it's about converting drivers using old interface to using the new one. We don't have to care about out of 3 drivers. That's a them problem and not our problem. So if we convert every in-kernel user to the new interface, we can drop the old interface. It's just that it's very tedious. It's a task that is not simple enough for kernel janitors to tackle, but it's not very interesting for advanced developers who want to do something fun. But as I said, this is not a hard problem. The hard problem is sys plus GPIO. So it's a major user of the legacy interface, but not in the way you would think. It actually uses the new descriptor-based interface, but the user space refers to GPIOs using the global number space. So we have to translate the numbers that we get from user space to the descriptors, and this is how we do it in the kernel. This is a hard problem because we advertise the kernel uAPI as indefinitely stable. So we cannot, for as long as users want to keep using this interface, we are stuck with it. And sys plus GPIO also has issues. First of all, just the same problem as for the legacy kernel interface. It's very brittle if you have shell scripts that refer to some random magic numbers, like 120, for a given GPIO, and then you have drivers that will come up, get probed in a different order, and these numbers don't mean anything anymore. You can, of course, scan the labels and then calculate the offsets from the base and from the base number and the offset of the GPIO, but that's rather unnecessary calculation in your script. It's quite feature poor compared to the character device, about which I will talk in a second. It doesn't implement many things. And the polling for interrupts is quite unreliable because it's not a buffer. You just get a notification about an event and then you have to read it very fast. But if you get enough events in a given time span, you will not be able to read all of them, so you can lose them. And so there has been an API inconsistency in sysfs that nobody noticed, and I just recently realized. So back in the days of the board files, if you exported a named GPIO, the link to it in sysfs would appear as its name. But for DT-based system, device tree-based system, that's no longer the case. That was a big change, and nobody ever noticed. I just realized when I was working on a thing recently, and that got fixed. I will give credit where it's due, though, and using the virtual file system actually is quite useful for fine-grained permission control, if that's what you're about, like give a user permissions to access just this one GPIO line, then that's what you can easily achieve using the file system. And also, the sys class GPIO works kind of like a centralized authority for all GPIOs, just that it's implemented in the kernel. So, as a maintainer, my long-term goal is to remove sys plus GPIO from the kernel entirely. But unfortunately, I have to first get everyone to stop using it. And so a quick note on kernel interfaces. It wouldn't be the first time that a kernel interface gets removed. So it is true that we're saying, okay, once it's carved in stone, it's API, we will support it indefinitely. But history knows at least a couple of instances of removing existing kernel interfaces. So there was a sys control system call, which was buggy, had problems with buffer overflows, and eventually it was removed. There was dev-kman, which was a special device providing access to kernel memory. It also got removed. There was devrow. Also some sysfs classes. So there was an RTC class under class MISC that was moved to class RTC and reworked. So it wouldn't be the first time that an interface from sysfs would be dropped. But the truth is that if user space objects to any such backward incompatible changes, then we must not remove them. And unless the interface is harmful, buggy, but this is not the case here. Yeah, so where are we at? Unfortunately, we are not close yet, and the problem is that I cannot really Donald Trump my way out of it and impose tariffs on sysfs. So I have to go the good way and just propose a set of alternatives. So the most obvious one is the character device, which has been around for almost 10 years now. And unfortunately, if you tell users that they have to drop their neat shell scripts that just write to files and use custom C code that includes uAPI kernel headers and calls various system calls, ioctls, then the reaction will be quite predictable. But, well, users want something that works simply. This is why we provided libgpiod and the set of command line GPIO tools. So libgpiod is a C library that wraps the kernel interface in a better, higher level API. We have bindings to Python, Rust, C++, G-object bindings as well, and of course command line tools. However, the character device inherently works with file descriptors, and file descriptors in Unix systems, when the last process that holds a reference to a given file descriptor exits, well, the file is closed. And that has caused a lot of confusion for people that were used to sysfs, because they realize very fast that the state of a GPIO is not guaranteed when GPIO set, the program that sets a GPIO value, exits. Because anyone can grab it, or even the driver can implement some default state to which the line reverts, and people naturally, instinctively assumed that GPIO set this GPIO to active will make it stay that way, but that's not the case. So I realized at some point that users do really want this state persistence, exactly what sysfs does. And I really like abstraction layers because there is no such problem that cannot be fixed with another abstraction layer. And I created this thing called GPIO Manager. This is a daemon that runs in the background and exposes a dbus interface with which you can interact using either the provided GPIO client or whatever library for dbus that you want to use. I presented it in detail during a talk last year, and what it allows you now is to simply do GPIO CLI request align, and then I'm actually, the slide is wrong. This should be GPIO CLI set, GPIO CLI get, but sorry for that. Basically, you request it, and the line stays requested because it's the daemon that is responsible for holding it, and then you can set its state, the daemon retains it, and then you can free it when you see fit. The problem is that people still, well, it has seen some adoption. I've integrated it in Meta Open Embedded. I've had people report back to me. I think someone started packaging it either in Debian or Ubuntu, I'm not sure. But there was some package maintainer that reached out to me with questions. But immediately, like for instance, after presenting GPIO Manager last year, I was approached by some people and saying, you know, it's neat and all, but I don't really want to change my programs because I have had my programs for a long time, and I want to keep them. So I thought that if you really cannot be convinced to change, you really want to keep using sysclass GPIO, do you really care whether the code for that runs in the kernel, or would you be okay if it ran in user space? So that idea occurred to me when I was looking for a project to learn Rust, and I figured that I need something that will be useful, that will keep me motivated to actually do a good job. And I figured that I will write an abstraction layer for sysfs in Rust in user space. And then I started looking at Rust because this was my first experience with it, and I figured that, yeah, Python is good enough, right? So now there is a thing called GPIOD sysfs proxy. This is what it is. Well, this is exactly that. This is an abstraction layer based on Fuse and using libgpiod to control GPIOs, implemented in user space. So you can get it from GitHub, you can get it from PyPy, And there are some things, so I would say that it's 99% compatible with sysfs. There is a problem with like limitations with fuse, so you cannot have multiple polars of a single file in fuse. And there is also no static GPIO base for chips. I'm working on it. I want to add it in some way, but I started consulting people who may have interest in that on how to approach it. So a configuration file listing labels of GPIO chips and their predefined bases or something like that's not ready yet. I will figure it out. I've written a comprehensive set of compatibility tests, and this script passes them. So I think it's rather compatible. You can get it from you can install from pip and just mount it on the directory of your choice, which typically would be sys class GPIO. But then you'll say, okay, but I disabled sys class GPIO in my kernel config. I don't have that directory, and I cannot mkdir GPIO in sys class. So what do I do? Well, you can use overlayfs. And I actually sent a patch to Greg KH adding a predefined mount point for sys class GPIO if this class is disabled, just like what we have for debugfs or configfs. He said that it's disgusting. He was very, very unhappy with it. And then I played with overlayfs and figured that I can simply overlay this directory on top of sys class. And I sent the response to him saying, I no longer need that patch. I can do it in user space. And he never responded. And I can imagine that his face looked something like this. So what's next for that? I want to support static, predefined, hard-coded GPIO base numbers. I want to get some traction for it, so please check it out. I still want to learn Rust, and I figured that maybe there would be interest in having a better file system-based interface for GPIOs. This is something that Linus Valeix, the co-maintainer for GPIO, floated some time ago. Like, I'm not against having a file system-based interface. Maybe you should work on a new one that would live in debugfs. But I'm like, okay, let's not add anything to the kernel. Let's do it in user space. And my to-do list is running over, but I intend to get to it at some point. And finally, well, the sys class GPIO will stay there for a while. We can remove it as long as it has users. We have alternatives in the form of libgpiod. We have a compatible alternative in the form of the sysfs proxy. And, the work continues on converting the kernel drivers, the legacy kernel drivers, to using the new API. And once we get that done, that will make a much more stronger case for removing the old interface and subsequently the GPIO class. And right on time. That's it. Thank you very much, and I'm open for questions. Question really?
Questions?
What are the alternatives for minimal user space, like when you mostly only want to use things like BusyBox or so?
I'm sorry, could you repeat?
So if you only want to use BusyBox, run some scripts and not even a full init, what are the alternatives then without having to start a bunch of daemons?
I think the question is...
I'm thinking about the answer. If you really just want BusyBox and not run anything other than BusyBox, then all the closest thing is running GPIO tools. They are very tiny. These are very tiny programs, and I guess you're not running only BusyBox. You typically will have something else, something on top of it. So the closest will be just running the GPIO tools.
Or you will make the GPIO tools in BusyBox.
I mean, yeah. Well, I'm not gonna, but knock yourself out.
So the Broadcom GPIO driver that's used on the Raspberry Pi has a kernel module parameter to enable GPIO persistence. So even if you release a line, it returns to the old value, and it's upstream. Why can't we have that for all GPIO controllers and just use GPIO set without having to use daemons? why only this one driver is allowed to have it and the others not? Couldn't we add like a flag and request, please, I want to have GPIO persistence, and the drivers just do the correct thing?
Do you have 3 hours? So
I am
joking,
actually registered for the embedded dinner. So if we sit next to each other, you can
I'm
tell me
joking,
about
but
it.
the idea of safe state property in device tree for GPIOs has been around for a while. We just couldn't get any traction for it with DT maintainers. And there is this idea that, we should actually limit the available states of GPIOs because some of them may be regulators that may damage hardware if they enter a certain state. Yes, that is an idea, but I'm not sure if it's going to go anywhere in the near future. But we can talk about it during the dinner.
Okay, but for Raspberry Pi it went somewhere, so why not?
I am not sure if it ever. So is it a kernel module? Is it a kernel parameter or is it a device tree property? Okay.
I'll just follow up on this gentleman over there. What happens if you have initramfs with just BusyBox? Basically, at that point, you do not have Python to run the proxy. You don't have potentially GPIO tools because you are limited in size. What now? You are left with the sysfs interface anyway. And actually, the sysfs interface for this stuff is nice because you can just echo stuff into sysfs attributes.
I do agree. Yes, that's another problem to think about, and maybe adding some limited subset of GPIO tools functionality to BusyBox is the way. I had a use case like that back in the day with I2C, and I actually added I2C tools to BusyBox because I required it in from FS. So that may be the way.
Or maybe the debugfs interface, a new one, a viable one.
That's
basically
I don't have an answer right now. I will think about it. However, it may be material for another talk at another conference.
You can always use configfs. Yeah, we already have gadgets in configfs, right? So if we add another interface for GPIO that is configurable through configfs. Okay, that's the end. Thank you.